Hi, in today's video, we're going to get familiar with some trig identities. Those identities will be used throughout chapter 5, and we will be getting familiar with quotient identities for today, reciprocal, Pythagorean, even and odd in the part 1 of this video. So quotient, reciprocal, Pythagorean, and even and odd. If you're taking calculus later on, this will be needed and you will need to memorize all those identities. For our pre-calc course, you will be allowed to use the identity sheet on quizzes and tests, but I would like to make sense of those identities using the unit circle. So that's why you guys see the unit circle to your right. We will start with quotient identities. And again, those identities should sound familiar from chapter 4, the quotient identities and the reciprocal identities. We all know that the tan is the sine over cosine. In terms of unit circle, it's the y coordinate over the x coordinate. So for example, if I'm finding the tan of 30 degrees, which is pi over 6, I'll do the sine over cosine, which is the y over x, which is in this case half over square root of 3 over 2, keep, change, flip, and we will get 1 over square root of 3, which could be rationalized by multiplying the top and bottom by square root of 3, and we get square root of 3 over 3. That's just a quick reminder on how to find a tan of an angle. If we want to find the cotan of an angle, we will divide cosine over sine, and that division idea is linked to the title, quotient. So this one would be x over y. So that's a quick reminder on how to find a tan. Reciprocal identities were also discussed in chapter 4. And I did teach you a little trick, my first and last name, my initials, S and C. You can always memorize that S comes with C. So sine and cosecant are reciprocal. Whether I write sine is 1 over cosecant or cosecant is 1 over sine, it simply means that sine and cosecant are reciprocal. Whichever one I need to find, if I am given the sine, I just need to flip it, and that way I'll find the cosecant. If I'm given the cosecant and I need to find the sine, I will also flip it to find the sine. Cosine and secant also C with us. So cosine and secant are reciprocal. So I can write it as cosine equal 1 over secant or secant equal 1 over cosine. It depends on what I'm finding. Tan is 1 over cotan or cotan is 1 over tan. Also, tan and cotan are reciprocal. That is one of the ideas we used in chapter 4. Here comes the new part, which is Pythagorean identities that we're going to talk about and explain for today, and even and odd. So let's start with Pythagorean identities. So those Pythagorean identities are new to you, but the term Pythagorean isn't. You guys don't know Pythagorean identities, but you do know Pythagorean theorem. And you guys know that we apply this theorem in a right angle triangle. Usually you have it memorized as a squared plus b squared equals c squared. I like it better when we memorize it as leg squared plus leg squared equals hypotenuse squared. So if we square a leg of a right angle triangle and we square the other leg, we add them up, we're going to get the square of the hypotenuse. What does that mean in terms of the unit circle? So let's look at this. Let's take any angle. If you can take pi over 4, any remarkable angle will make it easy on you. You can take, again, any angle. I will take 30 degrees, and I want to make that 90-degree angle, and I'll have this right triangle right here. If you guys did the unit circle project in Algebra 2 class, you will have the physical moving triangles. I showed you that project at the beginning of chapter 4. When I take this point and take it down, that will be the y value. Remember, this is an xy coordinate. This is the y-axis, and this is the x-axis. So that vertical coordinate will be the y, and this will be the x. And this is x, this is y. So let's square the x and square the y and add them up and see what do we get. If we square the x coordinate and square the y coordinate, when we square a fraction, we have to distribute the square to numerator and denominator. Square root of 3 squared, the square eliminates the square root. So the top will give us a 3, the bottom will give us 2 squared, which is 4. 1 squared and 2 squared will give us 1/4. If I add up 3/4 and 1/4, they will add up to 1. And let's check if hypotenuse squared is 1. If you guys remember at the very beginning of the unit circle, we talked about the hypotenuse, and the reason why we call it unit circle. Unit means 1. The hypotenuse is the radius, and the radius is always equal to 1. So this hypotenuse is actually 1. If I square the 1, 1 squared is 1. So that is true that x squared plus y squared equals 1. In terms of trig functions, the x is the cosine, the y is the sine. So if I square the cosine of an angle, I square the sine of the same angle. That's why I call it theta or x, or in this case, it was pi over 6. I should get 1. And this is where the Pythagorean identity comes from. Sine squared plus cosine squared equals 1. It's an addition, so it doesn't matter which order I write it. So sine squared plus cosine squared equals 1. And that will be identity 9. If you guys want to number them together, this is a 1. This is a 2. If you look at the personalized copy, you will see the same numbers. And the reason why we want to number them, because when we work on simplifying problems, we will be using identities. If we say I9, everyone will know that we use this one. It's like a common language. I'm gonna take this and just change the format a little, what we could use. So if I take this and I subtract cosine squared on each side, I will get sine squared equals 1 minus cosine squared. And that will be our identity 10. If I do the same thing, but instead I subtract sine squared, I will have cosine squared equals 1 minus sine squared. And that will be our identity 11. Let's talk a little bit about even and odd. So let's erase this part right here. When we talk about even and odd, we talked quickly about even and odd functions in general, not trig functions, but functions in general. We said algebraically, even and odd mean opposite input. If I get same output, those will be even functions. If I get opposite output, think about output as a result. That will be odd. So an easy way to memorize trig functions as even and odd, I want you to memorize that cosine and secant are even and everything else is odd. So cosine and secant are even. All the other four, which are sine, tan, cosecant, cotan, they are odd. Let's make sense of this before we end this video. I need opposite input, and the input in this case are angles. Opposite input, theta and negative theta in general. If I take a specific example, I want to take pi over 3 and negative pi over 3. Those are opposite input. And let's take a look at what stays the same and what changes. So let's take a different color and let's look at the x coordinate, which is the cosine. We can see how the cosine stays the same, which says here cosine of negative theta equal the cosine of theta. It stays the same, so same output. That's why it's an even function. Let's look at the sine. What happens to the sine of pi over 3 versus the sine of negative pi over 3? They are opposite of each other, which explains that negative right here. So opposite output, and that's why we have odd function. So in other words, the cosine of pi over 3 is, or the cosine of negative pi over 3 is the same as the cosine of pi over 3. That's why it's an even function. The sine of negative pi over 3 equal opposite sine of pi over 3. They're opposite of each other, which explains the odd function. You can generalize and say and memorize cosine and secant are even, all other functions are odd, and this what explains that negative right here next to all the other functions.